Hi guys, Mrs. H here. We're going to go ahead and review position versus time graphs and look at where forces would be applied to the position time graph as well as motion maps. So remember, position time graphs tell us position, velocity, and acceleration of an object on a graph. And so if we look here, move this. Okay, so if we look here at this position time graph, this should look familiar. This came right off of the PhET simulation. So if this is a car moving, if you'll notice at first the car is stopped for about 2 seconds, and then at a constant velocity in a positive direction moves for 2 seconds. Then at 4 seconds stops, at 6 seconds, the object will again move at a constant velocity, but this time in a negative direction, and then stops for a third time. After the third stop, that object is going to be accelerating. The object is going to be moving in a positive direction and speeding up. And so that would be the description of the motion. So where in that time frame, where do we see balance forces and where do we see unbalanced forces? So let's look at that now in a different light. So again, same graph. This time we're going to be describing the force. So I have circled the locations of an unbalanced force. So the circle indicates an unbalanced force being applied. At all other time periods, the forces are balanced. So there's 5 unbalanced forces acting on the car. This first one right here is due to the fact the car was stopped and then is now moving. So it has sped up. So at this instant, there's a quick applied unbalanced force. So now if you notice at the second circle, at the second unbalanced force, so originally the car was moving in a positive constant velocity and now has stopped. So again, the car slowed down. So we have slowing down, which is an acceleration. And so then we have an unbalanced force. So now again, we can move from a stopped to a speeding up. So again, a quick applied unbalanced force. Here we have them stopping, so they're slowing down. Again, a quick applied unbalanced force. So then what's happening here? So the object, remember, is speeding up. We see a curved line in this instance. So this is not a quick applied force. This is a prolonged, unbalanced applied force. And so we can see, looking at these position times graphs, where balanced and unbalanced forces are applied. So now let's take this and look at a motion map. And so remember, again, motion maps can give us position, velocity, and acceleration, but this time it's on a number line. So just as a quick review, because I know it's been a while, remember the vector represents the velocity, and the dot represents that should be a set time. I'm sorry about that, not a set time. So a set time. So 1 second, 1 minute. So in this scenario, the velocity is 3 meters per second because the object moved. Notice 1, 2, 3, 3 meters. This is 1 second. So 3 meters per 1 second, and it's in a positive direction, and they do that twice. So here's another example of, again, using the motion map to describe the object. This time it's a toy. So notice that these lines are the same in length. So that tells us that the object is moving at a constant velocity. Again, for 3 meters per second in the positive direction. So the forces acting on this toy are all balanced because there's no change in there's no change in velocity. It's not accelerating. And to give us a little more detail about the toy's motion, we could also say the toy was traveling for 4 seconds, the distance traveled was 12 meters, and that it started at -8 meters and then ended up at a positive 4 meters. But again, during that whole time, the object's motion is constant. There's no change in velocity, there's no change in direction, there's no change in speed. And so, therefore, it is all balanced forces. So now let's look at a different example. So now this time, notice those vectors change lines. So that means for each second, the velocity is different. So in this one, the ball is traveling in a negative direction, but it starts with a velocity of negative 4 meters per second. Then the next little section, if you notice, whoops, excuse me. The next little section, it only went 2 meters right here. So this is a negative 2 meters. And then this last one, it only went 1 meter. So notice those 3 seconds, there's a change in velocity. And so therefore, it's accelerating. And we can say that the ball is slowing down. So because there's an acceleration, the forces acting on this toy are all unbalanced. And again, if we want to give a little more detail, we can say that the ball traveled for 3 seconds and that it traveled a total of 7 meters in those 3 seconds. So where are forces acting on an object? And so I used again that green little circle to indicate where forces are being acted upon when I have different motions. So in this scenario, I have 3 different times or 3 different points on this motion map where an unbalanced force is applied. So if we notice here, we have a constant velocity. The vector lengths are the same. But between here and here, there's a change in the vector line. So that means the velocity changed. So I had to have had an unbalanced force occur here. Now on this one, I have the same length, so the velocities are the same. Now if we look here, this is actually changing direction. And remember, a change in direction results from an unbalanced force. So because this changed directions, I have an unbalanced force, even though if you notice, the velocity didn't change. So I have no change in velocity, no change in velocity, no change in velocity, but just that change in direction. So then again, what happens here? I have a shorter line, so this object is slowing down. And so again, I have an unbalanced force. So I have 3 points in time that I have applied an unbalanced force to this object, to the kid. So you're going to be practicing this today. If you have any questions on identifying where forces are acting on an object on a motion map or on a position time graph, please let me know. You're going to be practicing to that. Also double check to make sure when you're doing your assignment that you're identifying whether or not it's a position time graph or a velocity time graph, because those are different. Remember, velocity time graphs show acceleration on a straight line, just as a reminder. Hope this helped. Bye, guys.